Hello and welcome to the Sound on Sound People and Music Industry podcast with me, Sam Inglis. I'm very pleased today to be joined by Daniel Blackmer of Earthworks Microphones. Welcome, Daniel.
Great to be here. Thank you, Sam.
It's an absolute pleasure. I wonder if we could start this podcast by talking about a very important figure in the history of audio technology, your father, David Blackmer, who founded Earthworks. So I understand initially David founded Earthworks to develop loudspeakers rather than microphones. So how did the company end up being a microphone manufacturer?
Well, it's actually kind of a funny story. So when he originally founded the company, as the name implies, it was actually a construction company, not a audio company of any kind. He was just a lifelong electrical engineer, pioneer in the world of audio. Of course, everyone probably is familiar with DBX. But he then bought some property in New Hampshire and basically had some of the space available to him to kind of just have his own research lab. And that's exactly what he did. You know, he had some money from selling DBX and just kind of was more of a hobby shop than anything else. And his true passion was to develop the best loudspeaker. The true experience of a classical concert was really what he wanted to have. He loved classical music and would go to concerts and would have a certain experience and wanted to be able to recreate that experience at home and didn't feel that any of the equipment that existed at the time could create that. So he wanted to make the best loudspeaker, believing that was going to allow him to have that experience. But what wound up happening was when he was in the process of developing this loudspeaker, discovered that there was not a good enough measurement microphone to test the particular parameters of the loudspeaker he's trying to test. He went out and bought every one that existed at the time, and some of the really nice B&Ks came close, but they didn't quite do the transient response the way he wanted. So he created his own. And then there was a jazz pianist who would show up periodically at the facility to do various things, renderings and the like for him. And this guy heard these mics and said, "Oh my gosh, you need to make me a pair of those for my jazz piano recordings." And so my father did, and the guy kept showing up and badgering him that he needed to make these into a product. And that's literally the origin story of the company, was how we got into the microphone space.
And your father was actually building these microphones from the ground up in his premises?
Yes, he was. Although you should know about the originals was they were brass bodies that were, I don't know what the original body, the base of it was actually for. They were sort of hacked together XLRs, and the tips were these wand-like structures surrounded by putty. So, I mean, and I'm talking about like modeling clay, like children's modeling clay. So that was the original prototype microphone that this guy would have seen and has used. We still have a couple of these things kicking around on, the sort of the shelves at the office. But this was not a production-ready product in any way, shape, or form. You didn't have all nicely machined parts and everything, perfectly encapsulated and potted and all the other things that we do these days. The boards were all perf board with wire wraps and that sort of stuff. Didn't even have PCBs manufactured for them. So they were rough, but they obviously sounded phenomenal. So.
Well, as the fact that your father was unable to find an off-the-shelf measurement mic that did what he wanted would suggest, he was obviously very aware of the importance of transient response and ultrasonic frequencies. Can you explain why he thought that was so important?
Yeah, absolutely. It's actually kind of funny, and I'm really glad you bring this up, because it's one of the things about Earthworks that's, I'm not saying we go out of our way to fully explain this to everybody, because I'm well aware that it's a little arcane for a lot of people to understand what in the world we're talking about. No, people at Earthworks do not believe you can hear 25 kilohertz tones. That's not remotely what anyone's after. That's not what my father would believed. The basis behind what he was after, he was an electrical engineer first and foremost. And every electrical engineer will have studied impulse response and how impulse response decomposes using the Fourier transform into magnitude and phase. And so what he was really fixated on, what he believed to be the important component of audio that was missing, was the phase response. Like how linear phase response is maintained up until higher and higher frequencies. So the reason that you would want a extended, again, I'll use this term, quote unquote, frequency response. What they're really saying when in the audio world you say frequency response, what you're talking about is magnitude response. The reason that he would focus on having an extended magnitude frequency response out to 20, 30, 40 kilohertz, 50 kilohertz, etc., is because that maintains phase linearity 1 decade earlier. So if your magnitude response rolls off 50 kilohertz, your phase response will roll off at 5 kilohertz, right? 40 kilohertz, 4 kilohertz, etc. So what he was really fixated on was maintaining that really precise transient response, right? Having the impulse that is incredibly short, because the really short impulse response corresponds to a much more, again, within context of the magnitude response, equates to a much more linear phase response in the frequencies of interest. And it's one of those things that, again, we don't have a really great explainer on this anywhere. I know that my father and my brother did write a paper about this, but to me, they spent a lot of pages to dance around what I just said, I think, much more succinctly. But it's also one of those things that I'm fully aware, unless you studied electrical engineering, it's not necessarily something that people have an intuitive understanding of. So anyway, that's the basis behind why Earthworks does what we do with, even our logo is an impulse, right? That's why we really fixate on that so heavily.
So this issue of phase response, I guess a lot of us are so used to using conventional studio microphones that perhaps we don't notice. But at the same time, we always know whether we're listening to live sound or whether we're listening to reproduced sound. Is that part of that factor?
Partly. There's so many factors that go into that. Obviously it's everything from, and I'm not sure if this is the direction you're headed with this, but there's everything from ambient crowd noises and things that you pick up when you're listening to true quote unquote live sound versus sound that's been recorded and sampled in the studio, and different components have been combined together in Pro Tools or whatever. There's obviously a whole different kind of acoustic landscape to those relative sounds. But as far as capturing sound and I'll use this term loosely, but in the wild, on a stage and then being able to reuse that sound later, what you really need is good isolation, and great phase response is definitely a big component of capturing something that will sound like studio sound when you're live. Because again, some of those, there are some phenomenal studio microphones out there that most people are not going to go put on a stage anywhere. And that is definitely a component of the difference, is going to be, first off, how open the physical microphone is. Getting into some of the other components of what I would actually refer to as some of the mistakes my father made was related back to his belief that if you build it, they will come. So he had things like, pencil condenser microphones for vocals. You look at some of the original SR mics of ours, and to my estimation, there's no way that a vocalist would ever use that product, not because of the sound quality of the product, but because it didn't fit aesthetically with what they believed that a vocal mic should look like, especially a stage vocal mic. And so his belief was the technology would win out. And I think that we've discovered over time that it's less about the technology and the quality of the product and more about the psychology of how the user who will be using it thinks about it. And so basically sorry, it's a really long way of answering your question.
No, that's cool. So in order to capture this phase response, the linear phase response and the extended frequency response and the transient response, the key design factor, I guess, is the use of miniature capsules, smaller even than in most pencil mics. Can you explain the kind of pros and cons of that design choice?
Well, really, the main pro of that design choice is the mass of the diaphragm. Right, so the mass of the diaphragm being low guarantees that the amount of movement of the diaphragm, you're not going to have the inertia that a larger diaphragm will have, right? So the con of a larger diaphragm is going to be that it literally just has a lot of mass to it, comparatively speaking. I realize that you're talking about micrograms of difference here, but it's enough to make a noticeable difference in the transient response. If we go from a 6 millimeter capsule to a 9 millimeter capsule to a 14 millimeter capsule, all sizes Earthworks actually does use, we can see a physical difference in the impulse response when we use the tools we have to generate impulses, actual acoustic impulses. We can physically watch the diaphragm flutter, and you can definitely see a huge difference in the settling time of a 6 millimeter versus a 14 millimeter capsule. So the pro of it is the mass and the settling time. The con, of course, with these smaller diameter capsules is going to be noise floor. So the trade-off is always, how much noise is acceptable. Is 22 dBA acceptable? Is 27 dBA acceptable? Does it have to be down to 14 dBA? The real trick there, of course, is most people use compression, and compression amplifies noise. So depending on how they're using the tool, they can either look at it and go, oh my gosh, this is so much noise, or they can, deal with that differently. Anyway, that's really the pro and the con of using that particular technology. From that point on, there's a bunch of other things that we do to the capsules. We're not just relying on having a Back-Electret with the standard FET and then just feeding that through a small amplifier. There's other filtering and things that we do to achieve the impulse response we get out of it.
Back-Electret mics, talking of what you just said, are an area where there's been a huge amount of progress in the last 30, 40 years.
Yeah.
Do all Earthworks mics use this technology, or are some of them true condenser mics?
No, everyone we do is a Back-Electret. Back-Electrets have the major benefit that the pre-polarized component of it, that they have a PTFE layer on the back plate. So they're all Back-Electrets, as you mentioned. That we don't use any Electret mics. I do realize that there's most people don't know there's a distinction, but there actually is, depending on where the material is deposited that has the permanent charge. So the Back-Electret means the permanent charge is on the back plate, just to clarify that. So yeah, every one of our products is a Back-Electret for all the transient response reasons I said before. The huge benefit for us with that is that the pre-polarized voltage is somewhere around 300 volts on that Back-Electret, so we're able to get away with using phantom power and so forth. Some people who do true condenser microphones will use a voltage booster to get up to 60, 80 volts and so forth for their polarization voltage. But again, it's only 60 or 80 volts compared to the Back-Electrets are able to they do get about 300 volts of permanent charge on them. And so far, we've never had, in the history of the company that I'm aware of, we have never had a single microphone come back because the charge on the Electret was dissipated. I know that's something, I guess, sometime in the 70s, maybe the 80s, that was sort of a mythology floating around the audio world. I don't know the veracity of it, but I know that for us, it's never been an issue. So speaking to what you said a second ago about the quality of the Electret technology having improved pretty radically, we've basically been very, very lucky to have incredibly high quality capsules.
And what is the actual advantage of having a very high polarization voltage in a capsule?
Really, it's gain. If you think about it, everything's about charge, right? So it's like you basically have a lot of charge, so that when that diaphragm moves a very small amount, you get enough charge moved from that the buffering JFET is able to develop a real voltage from that.
And tell me a little bit about the electronics that are used in the Earthworks mics, because one thing I've noticed about all the models I've seen is that they all have relatively high current draw compared with a lot of microphones. The phantom power standard, I think, permits 10 milliamps to be drawn by a microphone, and most of the Earthworks mics come pretty close to that. What are you doing in the mics that initiate such a large current draw?
Actually, that's a really funny story, because my father, he knew that the phantom power standard, was using 6.8K resistors on pins 2 and 3, that basically, and with the 10 milliamps, he knew that would equate to 14.7 volts, right? So if you think about 48 minus 14.7 divided by 6.8K, you wind up with 4 point something milliamps per leg, right? So it's like almost, the sum of the two will be about 5 milliamps. So what he did was he actually developed a shunt Zener regulator and just regulated one of the legs to 14.7 volts, and then just servos the other leg to be exactly the same voltage. So the amplifier's output itself is the output of the servo. So it's actually like loop upon loop upon loop. So it's not a requirement of anything to do with the electronics. There's no specific conferred benefit of having that particularly high current draw, other than it just happens to mean that we have an offset voltage of basically, under a millivolt of offset voltage between pins 2 and 3, and we're able to run off 48 and 24 volt phantom power, because obviously 14.7 volts, technically speaking, you could also go and say, oh, well, you get the most dynamic range with a 48 volt phantom if you set your voltage to 24 volts. He looked at that and said, oh, well, the problem with setting it to 24 volts is you then can't run off 24 volt phantom. So that's not a good place to servo to. So instead, he servoed to 14.7. So then you'd have headroom with both 24 and 48 volt phantom standards. Now, that, of course, was the late 90s. So now I believe pretty much 48 is standard on everything. But at the time, he was thinking about making it a little bit more dynamic in terms of what other technologies to compare with. So there's no specific benefit to our amplifier to run off of that much current. I know that it's a question I get asked pretty endlessly at trade shows, but that's the reason for it. It's not for any specific benefit to the amplifier.
So the early Earthworks products, like the one that your father's jazz pianist friend used, targeted what you might call the established uses for small diaphragm mics, like classical recording, pianos, drum overheads, that sort of thing. Over the years, however, Earthworks has also produced mics targeting niches where you'd normally expect to find moving coil dynamic mics, close miking drums, stage vocal mics, and so on. What's involved in adapting this technology for those roles?
Well, honestly, especially for everything you just listed, the core technology itself is very well adapted to those uses. We have, especially when you look at things like our polar patterns, which we're able to achieve, using some patented technology that we have, as well as just sort of, the shaping of the tips and other things like that. We're able to get these really phenomenal polar patterns with these tremendous off-axis rejection characteristics at all frequencies, which again it's relatively unusual unto itself to see that. So we actually had those technologies already developed for the products that I was alluding to earlier, talking about how my father tried to say, hey, if we build it, they will come. The reality is, for us, it was just sticking those same things into different form factors that fit better with, you talked about close mic drumming. Well, close mic drumming, the products like our the DMs, the DPs and DMs now are newer drum mics. Those are able to obviously fit right on the tom and the snare and just have this very low profile and so forth. And so accordingly, that it's more fitting the form factor than the technology. The technology works phenomenally for that. And what's great is you get that off-axis rejection, so that you put it on a tom or a snare, and then somebody hits the cymbals above. You don't necessarily get a tremendous amount of cymbal in that particular mic. So they can really the mix engineer can really tune the output of their sound to what they want to hear from it. So for us, it was less a question of adapting our technology than it's really fitting it into a different form factor that allows the technology to really shine the way it does. Because things like percussion instruments are, you really want a good transient response. That's what you're looking for, because that's the sound that the person who's sitting there, trying to create the sound, that's what they're listening to.
One thing that's changed enormously since Earthworks was founded is that there's been a sort of low-cost revolution driven mainly by Chinese manufacturing and based mainly on old German designs that have sort of filtered through into that part of the world. Are Earthworks mics still manufactured in the USA?
Yes, they are, 100%. We have our manufacturing facility here in Milford, New Hampshire. We've got our own machine shop, and we do use some local vendors to do plating and some of the aluminum machining and so forth. We actually do at some other local machine shops, but yeah, everything's made here in the U.S. Obviously, circuit boards and the like are physically made in Asia. We have them populated at a local facility though. But again, that's just where if you go to a local board house, that's where they're going to have them made anyway. Unless you're a defense contractor, nobody has circuit boards made in the U.S. But otherwise, yeah, everything else is made here, and they're all hand tuned, hand tested still. Yeah, it's definitely both a point of pride for us, but it's also allows us to control our supply chains. So everyone's right now scrambling because of all the supply chain issues around the world, and we have enough on hand and enough raw material. Raw materials are a lot easier to get a hold of these days than a lot of other things. So we have enough of those on hand to actually be able to continue to manufacture, which is actually really nice as we're listening to a lot of our peers scramble to get their supply chains under control. So yeah, it's definitely something that allows us to both manufacture in more limited quantities when we have products that don't sell as much. When you go to Asia, you tend to be looking at minimum order quantities of 1,000 to 10,000 products, and so if we have something that we're expecting to sell fewer of than that, we can adapt ourselves around those sales expectations. Yeah, it's definitely been a great benefit to us. Obviously, the main cost is that it's very inexpensive to have things made in Asia, but at the end of the day, for us, it's still worthwhile making everything here in the U.S.
I guess that also makes you a more nimble company when it comes to innovating and developing new products.
Very much so, yes.
So I wondered if maybe you could talk us through what happens in the process of designing a new microphone. So how do you come up with the concept first and think, well, there's be a market for this, or do you have a technological breakthrough and you think about how you can realize that in a production microphone?
So for the most part, it's more looking at problem solving has been the more traditional way of going about it. So a great example of this, and I realize it's from a couple of years ago, but a great example of this was the development of the piano mic, where we were working with some engineers who in the studio said, "Oh my gosh, this pair of QTC40s above this piano is just the greatest sound we've ever captured on a piano ever. We want to figure out how to be able to do this, on a live stage." And so, we kind of worked with them and figured out what exactly they were looking for, and what the situation inside of a piano with the lid closed looked like, and how we'd have to equalize that to make that everything sound good, because obviously inside of a piano can be a little bit of an echoey environment, and different frequencies are boosted and so forth. So we sort of looked at that and said, okay, well, we already know that the end objective is to get a pair of QTC40s into a piano. And so how do we make that happen? How do we make the lid closable? How do we do this and that? So we developed that bar to basically allow people to position a pair of QTC40s, for all intents and purposes, that's what the piano mic is, a pair of QTC40s inside of a piano. And then we just tuned the response curve on each of the two capsules to basically have a higher frequency bump. So there's a bit of a bump around 30 kilohertz, so between 22 to 30K. So that then when the lid is closed, it basically naturally equalizes the response curve. So that's a perfect example of where we just knew what our objective was and just basically took the pieces of our technology that we had available to us and sort of put them together into a form factor that responded to that market need. It tends to be problem-solving products that are the most successful. Obviously, there's moving into the future. We're looking at the way we sort of see everything is you have a transducer, acoustic to electrical transducer, and then from the electrical side, at this point, everything becomes digital. So for us, really, it's taking what we do really, really well, which is to take the acoustic signal and turn it into an electrical signal, and then adapting it to whatever the current technology of the day is, whether it's a Dante interface or Ethernet or USB or wireless or whatever the other technology is. It's really just getting that signal through the transducer onto whatever the next thing is really our focus in the engineering department of development.
Well, I'm talking to you now through what I believe is the newest Earthworks product, which is the Ethos microphone. Tell us a little bit about this model.
So the Ethos is a studio vocal mic. It's really an absolutely phenomenal microphone. It was basically developed to be a replacement for the SV33 product, which we came up with a couple of years ago. It was just very, very difficult to manufacture. We actually got more orders on it than we thought we were going to, and it became problematic for us to source all the parts correctly for it. The windscreens were very difficult to make and so forth. So the Ethos is designed to be a replacement for that product in a very similar vein of application and quality and so forth. It actually it sounds even better than the SV33 did, though. Honestly, without that metal mesh grill around it, it really is just an absolutely phenomenal sounding product. It's got the 14 millimeter capsule in it, so it's got a lower noise floor, and basically it's just again for its application, it just makes you it gives you that nice presence where you can really come up on the microphone. You don't get too much proximity effect, but you do kind of get that nice rich vocal sound.
Yeah, it's also a very beautiful object, and that's the same with most of the Earthworks mics that you've released in recent years. The industrial design is absolutely phenomenal. That must be now a very serious part of your design process.
Oh, well, thank you very much. Yeah, I will give all the credit to a combination of the engineering team and Gareth Krauser, our CEO. He really just has a tremendous eye for aesthetic, and he really is he just keeps refining and iterating the designs with the design team until they come up with some truly phenomenal looking products. I mean, I'm talking to an icon here right now, and he said you're talking to an Ethos. I mean, they're both just really very, very unique styles, and yet tremendous. I've been in awe of his ability to just come up with these really utilitarian and yet refined looking designs. I don't know how else to describe it, but the SR314 is another one that he did a tremendous job on as well.
Yeah, absolutely. Utilitarian yet beautiful is a very good way of describing them. Well, thanks so much, Daniel. I've got one more question for you, which is more of a philosophical question, really. You mentioned just now about how it's your job to do that one stage in the recording chain the best you possibly can of converting an acoustic waveform to an electrical signal. And with your mics that are able to capture frequencies up to 80 kilohertz and capture the transient response of an acoustic signal absolutely perfectly. In a sense, you're throwing down a gauntlet to the rest of the recording chain there. You're saying, go on then, we can do this bit. What about your A to D converters and your recording system and your loudspeakers? Are you up to the challenge? I mean, do you think that modern recording and playback systems are up to this, or is there still progress to be made there?
So, I mean, I'm sure I'm going to butcher the quote if I tried to say it, but to believe that you've achieved perfection is to be the sort of failure or something along those lines. There's always innovation to be done, right? I mean, there's always improvement to be made. I think that there are some truly tremendous technologies out there these days. Obviously we have computers more powerful than the desktop computers we had in the 90s. In our pockets now, right? So all these pieces exist. The trick is always, how people choose to apply those technologies. So, we are focused on making the best thing we can with the assumption that somebody else, somewhere else in the chain, will recognize the value of improved audio. I mean, I'm sure that you've noticed over the last few years, just the quality of even cell phone conversations have improved radically with HD calling, right? You used to get the same thing with many other technologies where people will absolutely recognize the benefits when they're exposed to them. So for us, it's sort of it's this combination of we have a series of products that we've had for over two and a half decades now that do meet these certain standards, that we're well aware many other people who are many other pieces of the supply of the chain are not going to meet the exact specs and standards that we are trying to achieve. But we're also aware that there's that person out there who, like my father, when he was trying to develop the loudspeaker and he couldn't find the measurement mic that would achieve what he was trying to do, there are people out there who are trying to achieve that level of perfection. We've had this running joke in the company with our flex mics, which are our podium microphones, that we believe we tend to be they're used very commonly in churches, and we always say that we're always the third option they buy, because they tend to go out and there's some guy in the church who knows a little bit about audio and gets some an SM58 or something and some loudspeakers and basically says, okay, cool, we're good. And then they discover that there's a problem with that, so maybe they go out and buy, I don't know, a Shure Microflex or something. And then they discover that there's some issues, some feedback issues or something. And so then they come along and say, okay, what can we do to solve these problems? And so we're the third one they buy. And we hope that they have all their problems solved with our product. But the long and short of it is that it's not usually, especially the price point we've always been at, it's not usually something where people necessarily even know that they want that quality level or have these particular problems they're trying to solve when they first are looking. And so they tend to have the problem and go, what product exists out there that I can then go find that will deal with this thing I'm dealing with? And so we wish we could go out and just educate every consumer on the planet all at once, but we're pretty well aware that that's not how it works. That in a lot of cases, people, a microphone's a microphone's a microphone right up until you try to use one and go, oh, here are the drawbacks to this. And then you might say, what can I do to find the solution to that problem? And then you get another thing. And then you say, oh, here are the drawbacks to this product. And so that you iterate through that process. And, so we just want to make sure we provide what's needed so people can have that best quality piece of the chain, our specialized piece of the acoustic waveform to electrical conversion.
Well, thank you, Daniel. we wish you many more years of success in that vein. In the meantime, you've been listening to the Sound on Sound People and Music Industry podcast with me, Sam Inglis.
And be sure to check out the show notes page for this episode, where you'll find further information along with web links and details of all the other episodes. And just before you go, let me point you to the soundonsound.com/podcast website page, where you can explore what's playing on our other channels.